12 days from now, the eyes of every observatory on Earth will turn toward one mysterious visitor. 3I Atlas, a 33 billion-ton traveler from interstellar space, now awakened after its fiery brush with the sun. Don't mind the eerie rattling that astronomers joke sounds like a Halloween prop. This isn't fiction. It's the sound of a comet stirring back to life. On October 29, 2025, 3I Atlas slipped behind the sun, hidden at magnitude 9.5, far too faint for human eyes. But when it re-emerged, something caught the scientists' attention. Data from NASA's Jet Propulsion Laboratory showed subtle but real deviations in its motion. Tiny accelerations not explained by gravity alone. Was it alien technology or the raw, chaotic physics of an active comet? Before we drift into speculation, let's anchor ourselves in the facts, in what science truly sees right now. If you love deep dive space storytelling, tap like so this episode reaches more skywatchers. For several tense days, 3I Atlas vanished in the sun's glare, unreachable to Earth-based telescopes. The blackout wasn't total. NASA's distant punch stack teased a faint, magnitude 9.5 glow. Steady, silent, and featureless. No tail, no dramatic jets, just a compact smudge near the solar edge. As November began, the glare eased and the comet's elongation widened, giving ground scopes a narrow window to hunt it again. Images stayed uncertain. The coma unresolved, the tail barely hinted. But one truth cut through the noise. 3I Atlas survived perihelion, and each dawn sharpened its position and deepened its story. What do you think is driving the odd motion? Jets or something stranger? Comment your theory below. When scientists compared 3I Atlas's predicted path with its observed one, they found a tiny but real drift, just a few arcseconds, yet enough to spark curiosity. Not alien propulsion, but cometary life in motion. Astronomers explain it using A1 and A2, parameters that measure subtle, non-gravitational pushes caused by jets of gas. As one JPL expert said, "We're not seeing a spaceship, just physics, magnified by a restless sun." Around every comet swirls an invisible drama, a battle of plasma, magnetism, and sunlight. 5 key processes shape this arena. First comes photoionization, where ultraviolet light knocks electrons off gas molecules streaming from the comet. Then charge exchange, as solar wind ions collide with cometary atoms, lighting up in X-rays. Next is mass loading, the flood of new ions slowing the solar wind and reshaping magnetic lines. Fourth, the bow shock, the invisible wave where the solar wind slams into the comet's expanding atmosphere. And finally, the ionopause, the boundary where the comet's own charged particles push back, carving a protective magnetic bubble around it. At this very moment, 3I Atlas is living inside that plasma bubble, its environment shifting with every breath of solar wind. But the plasma is only half the story. The dust near 3I Atlas is alive with electricity. Each grain, bombarded by sunlight and high-energy particles, builds up charge until it snaps, a miniature explosion that shatters the grain into smaller fragments. These fragments, light and highly charged, are whipped around by solar forces, creating sudden flickers in brightness and unpredictable shifts in motion. Now every shimmer in 3I Atlas's glow could be another invisible dust detonation, playing out across millions of kilometers of space. During Rosetta's mission, one moment became legendary. In July 2015, a coronal mass ejection from the sun struck Comet 67P. In just hours, Rosetta's instruments recorded the local magnetic field jump from 50 nanotesla to nearly 300. It was a revelation. Comets don't just react, they transform. Their plasma cocoons can swell, shatter, and reform in minutes. The event showed that a solar storm can turn a comet's calm, magnetic bubble into a chaotic storm front. For plasma physicists, this became a textbook example of how the sun's fury reshapes everything in its path. Fast forward to October 21, 2025. The sun erupts again, a massive coronal mass ejection from active region 42-6. The shockwave, racing at over 1,000 kilometers per second, could have reached Atlas in 2 to 3 days, right as it rounded the far side of the sun. No spacecraft was there to record it, but physics doesn't lie. If that wave struck, it would have amplified the comet's magnetic field, compressed its plasma shell, and disrupted its tail, just like Rosetta's 2015 encounter. For many researchers, that CME remains the leading suspect behind any sudden changes in the comet's brightness or path. Whether confirmed or not, it's a reminder. Even in deep space, the sun's breath can shake an interstellar traveler to its core. Despite all we know, 3I Atlas still hides its secrets. No spacecraft has flown near it, so every clue comes from distant light and indirect data. Its nucleus may span a few hundred meters, perhaps a kilometer. Its shape and spin still unknown. The tail is faint, maybe stripped by solar wind, yet its behavior fits a modestly active comet stirred by a volatile sun. As new images arrive, scientists hope to narrow the mysteries and uncover what this interstellar visitor truly is. November is the month of opportunity. On the 4th, Venus, the Sun, and the comet align in near-perfect geometry, a sight beautiful but deceptive, because the comet lies too close to the Sun's glare for easy viewing. Between November 14th and 17th, it becomes visible to dedicated stargazers with mid-sized telescopes under dark skies. December 19th marks its closest pass to Earth, 1.8 astronomical units away, faint but perfectly placed in the constellation Leo. And by early January, as Atlas aligns with Jupiter, Mars, and Venus, a brief cosmic choreography unfolds across the heavens. In the end, the data tell a simple story. 3I Atlas reached perihelion at 1.44 astronomical units, shining dimly at magnitude 9.5. Its motion shows measurable non-gravitational acceleration, not engines, but venting gas. Its plasma may have flared under a solar storm, and its tail may have faltered under magnetic pressure. But through it all, it endured. The mystery of 3I Atlas isn't about aliens or anomalies. It's about the timeless dance between ice, rock, and light. The story of how a fragment born in another star system now whispers its secrets to ours. Each new measurement adds a pixel to the picture, reminding us that science advances not through speculation, but through patience, precision, and wonder. So as November skies brighten and 3I Atlas drifts outward into darkness, remember, we are watching a traveler from another world, and every faint shimmer of its light is a message across the void, saying simply, I was here. If this journey moved you, like, subscribe, and comment, I was here. It helps the algorithm and tells future travelers we were watching.